Hey guys, so we're going to go over the top 5 questions from that Mathspace on factoring because as you can see, we have a pretty decent amount of people who struggled on a few of these questions. This came from my period 2 class. However, period 9, you had pretty much the same questions wrong. So we're still going to go over these. So the first question is, if it wants to load. Here we go. Finding the greatest common factor. Okay, so with this, when you have to find your greatest common factor, you are simply looking at, well, what do they share, right? So what do these have in common? Well, one thing they definitely have in common is they both have a U, and they also both have a V. So that's definitely our first thing. I'm going to take the U out. I'm going to take the V out. Once you figure out that they have the same letters in common, you're going to look at the smallest exponent. So for the V, it's a 2. And for the U, it's a 5. You always take the smallest one out because if you take the bigger one, you're going to be left with negatives in the other problem. Okay. So once you do that, you simply subtract the smallest exponent. So I'm subtracting a 5 from each U and I'm subtracting a 2 from each V. That would then leave me with the smallest ones disappearing and then just subtracting. So 6 minus 5 is 1, so U to the first. 3 minus 2 is 1, so V to the first. And that would be our fully factored form. Now the question itself is asking, well, what is the greatest common factor? So the greatest common factor would just be the part in front. So U to the 5th, V to the 2nd. Okay. Okay. So now the next question. Determine which of the following are factored correctly. Okay. So, or fully factored, I should say. So first of all, when you see something like this, where you already have 2 sets of parentheses, they're already fully factored for the most part. I'm not going to say always, because you do want to check x minus 5, nothing in common, x plus y, nothing in common. Same thing here, a plus 11, nothing in common, a plus 2, nothing in common. So it's definitely these two. When I look at the other two, they both have this second set of parentheses that are identical. So that means I can actually factor them further. And these would be a plus 2b, and then the values in front get their own grouping, 3x plus 2. So it was an almost completed grouping method. Okay, and then the last one would be this. But again, the first two were already completely factored. That's what we're looking for. So those would be our answers. Okay. The third one says fully factor it. Well, that is basically what I was just showing you. What I was just showing you in the last sets of problems. When we look at this, we notice they have the identical parentheses. So we're going to take those out because I can pull them as a common factor. And then whatever's in front gets its own grouping. So 5w plus x. So again, it was a non-fully factored grouping. They had it almost done. They just didn't finish it off. Okay, so again, the grouping, the parentheses that they shared, and then what was in front of each grouping gets their own sets of parentheses. Okay. Same thing exactly is going to happen for the fourth problem. You would take the 5x squared plus 4 and pull it out. And actually, let me do that because it is slightly different. Okay, so again, the 5y squared plus 2x, that's identical. So I'm pulling that out. Now what's left goes in front. So it's easy to see the first one, the 4z, but then it's minus and nothing there. Remember, there's always a 1 in place in front. So you do have that 1 you have to put down as part of the factor. Okay, so 5y squared plus 2x times 4z minus 1. And then our very last problem. Okay. Again, we want to factor that completely. So we're going to look for GCFs first and then see what else we can do. So let me rewrite this. 9x squared, y squared, z squared plus 10x, y, z minus 7x squared. So the first thing we're going to do, look at your numbers. So 9, 10, -7, nothing in common. So look at something else. All of them have an x though. So that I can definitely take out, right? So if I take the x out, what you're left with, and we're taking a 1, that's your smallest one. So we're going to subtract 1 from each of those. We're left with 9x, y squared, z squared, plus 10. This x cancels out. yz minus 7x. Close it. You cannot do anything else with that inside. There's definitely nothing left in common, and there's no smaller way of making it. So we can simply type out what we're left with that GCF in front, and then you're fully factored. Okay, so hopefully this helped clear it up if you were one of those people who had some trouble with these types of factoring questions.